All right, let's dive straight into this explainer and start building your ultimate developer's toolkit for the AP Computer Science A exam. If you're aiming for that perfect score, you already know that understanding Java's core mechanics isn't just about memorizing syntax, right? It's about knowing exactly which tool to reach for when you're staring down a really complex problem. So today, we're going to synthesize the crucial concepts you absolutely need to write efficient, bulletproof code.
Here's our roadmap for the explainer. We've got dynamic storage with array lists, mastering immutable strings, class connections and inheritance, the art of typecasting, and unlocking recursive logic. Let's hit the ground running.
Section 1. Dynamic storage with array lists, flexible data management. Think about standard arrays for a second. They're basically rigid boxes, right? Once you make one, its size is locked in forever, and you check that size using the length property. But array lists, they're totally different. Sitting right there in the java.util package, they're more like flexible backpacks. They dynamically grow and shrink on the fly as you add or remove stuff. So instead of length, we use the size method. Oh, and one other huge difference you gotta remember. Array lists can only hold object references. No primitive data types allowed. So no lowercase int or double, only objects. Now, you don't need to memorize the entire Java API for the exam, but you absolutely have to lock down these 6 core methods from the AP Quick Reference. You've got size, to check how many elements are currently in there. The 2 add methods let you either slap an object onto the very end or squeeze one in at a specific index, which, by the way, shift everything else over to make room. Then you've got get to pull an item out, set to swap one out at a specific spot, and remove to delete an item entirely. And remember, removing an item shrinks the overall size and shuffles all the remaining elements back down to fill the gap.
Okay, listen up because this is a massive trap. The AP test absolutely loves to catch people on traversals. If you're looping through an array list using an enhanced for loop, do not, I repeat, do not try to add or remove elements at the same time. If you mess with the size of an array list while traversing it like that, your program is going to immediately crash with a concurrent modification exception. Literally just crashes. So always keep that in the back of your mind.
Moving right along to Section 2, mastering immutable strings and handling text safely.
Here's the big takeaway for this one. Strings, which are just hanging out in the default java.lang package, so you don't even have to import them, are completely immutable. This is a total game changer. Once you create a string object, its exact sequence of characters is locked in, set in stone. When you call methods that kind of look like they're changing the text, like shifting it all to uppercase or grabbing a slice of it, those methods aren't actually touching the original string. Nope, they're actually creating and returning a brand new string object.
And just like with array lists, the AP Quick Reference highlights specific string methods you absolutely need to know to dodge the dreaded index out of bounds exception. You'll need length for the character count. The 2 substring methods are super important. One pulls from a starting point all the way to the end, and the other grabs a chunk between 2 specific indices. But hey, remember, that second one stops exactly 1 character short of the 2 index. You'll also use index of to pinpoint where a specific string starts. And finally, when you're comparing strings, never ever use the double equals sign. Use the equals method to check if the content is exactly the same, or compare 2 to figure out their alphabetical ordering. All right, Section 3, class connections and inheritance, structuring your architecture. So, how do we actually structure data and behaviors in Java? Well, we organize them into these handy blueprints we call classes. And we protect the data inside those blueprints using a concept called encapsulation. This ensures that objects manage their own state safely. How? By making your variables private, completely hiding them from the outside world. Then you write public methods, constructors to set things up, accessors to read the data, and mutators to safely change it. It's basically how you enforce the rules and keep your data squeaky clean. Now, when these classes start interacting, we often run into the ISA relationship, better known as inheritance. This hierarchy is magic. It lets a subclass, say a dog, use all the code from a superclass, like animal, without you having to rewrite a single line of it. The dog just automatically gets the animal's attributes and methods. But it can also override them to do its own thing, like barking instead of making some generic noise. Oh, and fun fact, absolutely every class in Java ultimately inherits from the granddaddy of them all, the master object class.
Welcome to Section 4, the art of typecasting, safely shifting perspectives.
Okay, we're entering the danger zone of our toolkit now, typecasting. This builds right on top of inheritance and really lets us unlock the power of polymorphism. Here's the secret. Typecasting doesn't actually change the physical object sitting in memory, not at all. It just changes the reference you're using to look at it. Think of it like swapping remote controls for the exact same TV. The TV hasn't changed one bit, but depending on which remote you're holding, the buttons you're allowed to press, or in Java's case, the methods you can call, might be totally different.
Look at this stark contrast in safety here. Upcasting is when you treat a subclass like its superclass, basically treating a dog just as an animal. This happens automatically, and it's 100% safe because, well, a dog is always an animal. Sure, you temporarily lose access to the dog's specific methods, but it's super handy for stuffing different objects into a single array list. Downcasting, on the other hand, that's the exact reverse. It's a highly risky manual maneuver where you try to force a parent reference to act like a child, usually just so you can get those specific subclass behaviors back. So that naturally brings up a pretty massive issue. What happens if an animal reference is holding just a generic animal object, or even worse, a cat object, and we try to manually force the compiler to view it through a dog reference? What actually happens?
Well, it's a trap, and the AP exam absolutely loves to test it. If you lie to the compiler about what an object genuinely is during a manual downcast, the compiler won't catch it while you're typing. It'll just trust you. But the second you run it, bam, the program crashes immediately with a class cast exception. To completely avoid that crash, you've got to follow a very specific set of steps. Your ultimate safety net here is the instance of operator. Before you even think about attempting a downcast with those parentheses, you write an if statement to verify what the object actually is, something like if animal instance of dog. Then, and literally only then, do you actually perform the manual downcast to safely unlock those specific dog methods. And finally, Section 5, unlocking recursive logic, methods calling themselves. When you have a method that calls itself, you're opening up a really powerful but super delicate architectural door. Every single valid recursive method has to have two perfectly balanced elements to work. First, the base case. That's your exit strategy. It literally halts the recursion so you don't spiral into an infinite loop. Then you have the recursive case, which is where the method actually calls itself. But here's the critical part. The parameter values you pass into that recursive call must capture the progress of the recursion. Think of it like a loop control variable counting down. Every single step has to bring you closer and closer to that base case. At the end of the day, recursion really isn't magic. It's just another tool in your belt, a different flavor of repetition. Anything you can pull off with a while loop or a for loop, you can absolutely do with recursion and vice versa. The cool, unique thing about recursion, though, is that every single time the method calls itself, it gets a brand new, fresh set of local variables to play with in memory. So, from the flexible storage of array lists and the unchangeable nature of strings, all the way to class architecture, the tricky maneuvering of typecasting, and the elegant repetition of recursion, you've now got a seriously robust framework. Keep this developer's toolkit fresh in your mind, dodge those common exceptions we talked about, and you'll be golden. You've got the tools. Now, the real question is, are you just going to memorize syntax, or are you ready to engineer truly bulletproof solutions when exam day arrives?